morning. Let's put some music here. Where's the scene switcher? It's in sync. Um, where is the music? Let's put some. I'm just put some updates here in my channel. Very fast load. I want to open the. Let me see if there's some other prerequisite on that. This makes sense. So let's do that. Tomorrow I'll become like I was saying. Uh, where's the audio from? Ah, it's here. It was too low. So today I want to. This music is very. Let's put some other music. It's too loud, right? Let's reduce it a little. Very. What's the loud? I want the opposite from that. I can just loud D. Yes. Loud. Yeah, makes sense. So to I want to lower. Okay. I don't need to. I need to be focused right now because I want to begin this course tomorrow probably. and it uses Haskell. And because of that, and also you use a lot of the fact monad. So today, what I need to do is rush this effect to finish that, the fact monad chapter, right? Um, book here. So I want to rush this chapter, effect monad, so I can finish that. We are very close to finish that. We are already solving the exercise, right? And I want at least to know net effects here, so I can probably begin I probably begin Haskell part, right? Uh, so to Haskell, I have this I have this I have a bookmark here on an article showing the difference between Haskell and PureScript. It's somewhere here, but I have this article that I'll go after I finish this effect monad, right? Um, because with that I have all prerequisite. Brian, where's Brian? Come on, Brian. Requisites to I have all requisites to begin the course solving the fact monad, and this difference from Haskell article, right? That I need to keep in mind to go through the course. So let's do that. Let's see here. After this done effects, we're gonna have this done effects. I could of course I will uh, skip to for today because I'm in rushing mode. The after someday after I finish the Plutus program, I'll probably go there to to finish that. And let's see what more. We have some more exercise, yeah, and that's it. So let's do that. Today is an important day. I got really need to rush, and I probably not keep struggling in the exercise. I will pick the solutions to move forward, move faster, right? So we are on this. If I remember, we are trying to solve. Um, let me see if the audio is okay. Just a second. Okay, very nice. Um, so let me see. Write a function filter m which generalize. I need some water. Just a second, I'll be back. Okay, so write a function filter which generalize the filter function on lists. You should have the following types of signature. So it receives a filtering function, which returns a monad boolean value, and it receives a list and should return the sum monad from boolean and the list wrapped with the list. Right. So I begin to write that with pure new here just to see how that would work. Let's see. Here we have the test, so we are passing only positives. Only positives? Ah, I see. This is the filtering function here, okay? It's return the monad, array monad, having boolean values. My cat wants to be shown on the string too. Come on. This is my cat. Its name is Pipoca. Come on out here. See what she wants to go off. Get out. Come on. Keep the door open so she can leave. Okay, she leave. What's the past of leave? Leave it. To leave. What? Why my keyboard just stop working? What the? Oh. Okay. No, not live. Leave. Leave it. Has lived? No. Has left. Yeah, makes sense. Uh, okay. So here we are. Filter. Okay. Okay. Only positives. Returns are array monad having boolean values, and this only positive function should return the same array monad with the list internally. Okay. And this list should have only the positive numbers. Uh-huh. Okay. First step has been made. Like empty should be okay. Passing all positives with new. A list like here should just return the same monad with new. In this case, because only positives returns array, we're gonna keep that array with new. Otherwise, we should have that's is the place where the things become complicated, because I need somehow to filter list. I have this filter function already in place. Let's look for that in PureScript. Filter, okay. There is a filter for lists. It's imported here, and it returns it takes a list and returns another list. The problem is here is that this function is returning the monad boolean, right? So here I probably should use something like do notation to like I don't know, takes out this boolean. For example, should have something called I should have a boolean value called, let me see, fn line having I don't know if I call that fn line. Let's call this, I don't know, just R, and this R is result of calling fn. That's the problem. I need to call this function directly. I should not. I should use filter function for that. I had looked over that fold m function, which is very similar to the type signature here is very similar to what I need. And there is also, of course, this filter function. It's very similar to that too. But in case of filter function, this function is not wrapped in the maybe. Oh, sorry, into the monad. This is very similar. I can pass that. This is not. If I don't use the filter function, I could of course call fn with the wrap the let me see xs value. Let's put that just I don't know x, yeah, xs is the list, x the value, and to do that I need to unwrap xs x value, so I have each value of the list. Okay, and I can pass that to fn. Okay, pass that to fn. That would remember that the monad must be the same. Okay, so for example here this is not gonna work because I'm taking out the list monad. So to do something like that, I need to like do yeah, this is not gonna work because I need to somehow a list, I remember that a list have a head and a tail, right? What if I take the head what if I do recursive call on that with each element of the list? For example, I pass the head of the list to the function. It's gonna return a monad with a boolean result and wrap that. And if that's true, I return that value the rest filter of list. Otherwise, I just return the rest of return of that list. That would be possible, right? At least to solve the problem. To do that, I should call cons over a head of the like that, and the list having the tail. Okay, and so I can do something like call fn with that x, right? With e from the list. That would return a array with a monad, and I can like call pure. Uh, I should check, right? If I should check if R is true, then actually let me try to, instead of, because all the notation is not so useful, let's try so use bind here. So fn over that x should be uh, rest, where rest takes what? Let's put that xs and ys for now. And here it's gonna take x, which the list element here, or unwrap the list element. Let me see. This is the unwrapped value actually. So calling this, I'm calling just the value. Ah, I see. Okay. And here we're gonna have the boolean value, right? So this is m line. The boolean is actually a monad. Let's call that something else, like I don't know, mn. That mn should be tested. So I need to call if this thing is a monad, I can apply a function to that, right? So I can use map function instead. Also is applicative, so I can call that like this, and take here. I can take here the monad value, and I can, let's call this mr, because no, let's call this mv, right? So I can check the value the value rest mv. What do we do with that? We test that. So rest with true should return, let me see, xs cons xs. I can use like list construction here. I don't know. Let's put that way. Of course, I can append that, right? I can append that too. No problem with that. Because we know that list is from same group. Let me see. Same group allow us to append things. List is same group. Let me see, same group. There is no same group for list here, but probably in list we should have that. Same group list. Okay, so I can append together. Rest false is just that. But there's a problem here. I should not return the remaining list. I should return the recursive call of fn over that thing, right? And let's rename that function to handle. Let me see. Check process. Is that right? Yeah. So if it process true, and let's call this res, and that res should be this, right? Let me see now what is gonna happen here. Uno list. I should use because lists are tiny, right? So to do that, let me remember how lists work. me see. I have passed through this, but I don't have anything. Maybe with the exercise, let me see. Not for lists. Here, I should I should not use lists here. But why? It's here. Ah, okay. I don't want to deconstruct the the remain list. That's why we should use only that. Sense. It makes sense. I'll shut down that for today. I know I am wrong. I should not, but I'm in rush mode, so I am denied to check Twitter today. I will not check Twitter today. Should not uh, be lazy with that. Okay, one problem. Let me see. This problem, the best way to solve that, I know. I'm just, you know, trying to move forward. Fn with type boolean. I see. Because filter, it's expected that I should use here filter m instead, not filter, right? In byte group, filter m, while check the expression harass has type E0. Uh, because I don't know. While check the type M1 list, I see I'm returning a monad over there. So if I will return the monad, I should of course apply the monad. Actually, I need to apply something to that monad. To do that, I should, let me see what I should do to apply that, to handle that. Actually, hmm I can append something to rest because rest is not the list. Rest is the monad having the list. How do I solve that? I can append because XS I can pure on that, right? And apply that so to the rest, which is of course a monad too. Alright? So here I'm making the same monad as this, then I can append them together with apply. Uh, it's deposit. Let me see. Let me see. Rest returns a monad. Uh, let me see. Rest return a monad of a list. And by doing this, I am wrapping XS on the same monad. So now I can do that. I don't know because monad is not apply. Monad is monad has applied instance. So if a monad have a function that applies side effects, I can apply that. But that's the case here. Which argument is returning value is taking? You know, he's not taking anything. Let me see. It's gonna throw here probably. Yeah. Theorem checks with pure x has type T, 0. It's a monad having a side effect. Internet type T3, T4 with type. So I have a list. No, I have a monad, but I don't have a side effect on that. So the thing that should happen here is this filter should take a thing to compose that. I guess that I need to call rest, map it over that. Rest, what is rest here? Rest is a monad having list, right? Okay, so rest is the value. Rest is the value. Something must be applied to that rest value, right? What's gonna be applied to that rest value is I don't know, the XS value. But okay, XS is actually E right here. So it can be applied. So I need to create so I must have a function here that takes the y-axis line value and wrap that and call cons xs value and ys line. By doing that, by doing that, I have a side effect function that can be applied mm-hmm. So I am wrapping this in the monad of rest because filter m returns a monad right here. So I am wrapping that side effect function and the same monad and applying that side effect function that builds the list on that rest function. So now we have this problem here. Let's see. Filter filter m while checking that expression ys line cons xs ys line has type t0. I should call pure on that so I can wrap that function, side effect function, on the monad, right? Let me see. The music just go stop it. Why? The connection has dropped. I'm still streaming. I hope that I still streaming. Let me refresh that. Let's close and open that again. So now we have a new problem here. Let me see. So let's see, what is fn? Is a function that returns a monad value. Here we have this function, and we are passing this wrapped value to the function, which is return the monad. And here we need to put that process, which is a side effect function, right, inside of the same monad. So to do that, I need to put pure on that, I guess. Let me see. We still have a problem here. Let me see. Okay, let's see here. in bind group filter and while check the expression apply pure process. So here we have process is a function that, let me see, in bind group filter while check the expression apply pure process fnxs has type mlist a1, which is the returning value there, okay. While trying to match type m0 list array1 with type list array1. I guess the problem is right here. Okay. Let's put that process monad. While in bind group filter while check the express pure rest has type t0. Because filter our returns, let me see, a monad, right? I guess that this pure here does not make sense because filter returns a monad. Yeah. But here I need a function, right? So here we have a problem. Here I don't have a problem because I am wrapping a side effect function on the same rest monad, and I'm applying that to that returning list A. So no problem here, but here I have a problem because fn returns a monad, and here I am applying a monad to another monad, so it does not make sense. I have a monad here with that rest, right? So what I should have here is a function. Yeah, I should use the same structure, like ys, I guess, yes, ys, and that applied to the rest. Hey, Karepko. Thanks for the ride. Hey, Scabro. How are you doing? Yeah, thanks again for the ride. No problem, Karepko. Ah. So today we are rushing on that fact monad. I want to be able to finish at least the the minimal things here, because tomorrow I will um, tomorrow I attend to a course over the Bluetooth platform for Cardano, and it uses Haskell behind. And I have seen that there is some prerequisites to that, like knowing the fact monad from Haskell and a little basic of Haskell. So I hope that I can finish that today, and we are very close to that. And also, I hope that I can at least read. There's an article that shows the difference between Haskell and PureScript. You know, the type class difference and things like that. So I hope to be able to begin tomorrow with a little of Haskell because of that. And the course is more like to know the Plutus platform. It's built on top of Haskell. So the content course is that those things in there. I don't know anything of that. What's that? But I know that Plutus is because it was sent to me before. I know that Plutus has a lot of uh, content on top of Haskell. Hey JP, welcome. So that's what I'm doing. In here I have this exercise that I'm trying to solve right now. The filter I need to write a function called filter which generalizes filter function on lists. Your function have the following type signature. So I have the filter function. Normally I have this here. Okay, this is the original filter function for lists, right? So I have a callback function here that returns Boolean values. It receives a list and returns another list, a filter list, according to this callback function. If it's returned true, it's inside of the return list. It's otherwise, it should taken off. I have also this foldem function here, just noted here because I have seen that this very similar to filter type signature. So I'm not using right now, but just kept here to I don't know, maybe help somehow. And so I begin to write that. The test right here. I have passed to the test. The callback function is on positive, takes int values and returns the array monad with Boolean values. And we can see that here. So it takes each value of the list and returns true if it's positive. The first is array passing, so if I pass only positives with new, it returns an array of new. I have that by using this implementation here. So receiving a filtering function with a new list, we just return pure new because this pure is gonna wrap that new value over that m monad. And for the other case, we have that no-if case here, which pass a list having numbers inside of a list, right? Numbers inside, numbers inside of a list, and that should be equal to the array monad because again the array is being returned here in the callback function, and that array should wrap this filter list, right, with just 2, 4, and new values. And that should happen here. Let me just change this one. It's keep inside my head. Okay. So up to now, I am trying to do something here. I don't know if it's the best way, but I just trying. What I'm doing here, I'm receiving this callback function that takes the list, right, the head and list and the tail of the list, and I am trying to, because this function here returns a Boolean monad, right? So I'm trying to process that Boolean value over the head of the list, and somehow I still figuring out how uh, recursive call that filter and list of the tail of the list. So I'm gonna process that head list. That's the way that I'm going through. I don't know if there's performance of that. It's probably not the best way because of that recursive calls, but I don't know. It's the way that I'm trying right now. So I called this fn over that head item of the list, and apply process m function over that monad value right here, right? So with that, I am sure that I'm gonna receive a true or false on that process m function, right? Um, but I don't know if that's correct because mm, okay, a lot better now. So I don't know if is that correct because I know that here I should have a side effect function wrapped in the monad, and I guess that I need to call that with pure probably here, right? So I can wrap this side effect function, and I should call this function process m value just to differentiate that. It's not a monad, but it's the monad value, right? So having that, now I can handle true or false. Then if it's true, I can call, I have the rest of the list here, which is the recursive call over that filter and passing the boolean and the rest of the list. That 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 rest value should be a monad having a list, a filter list, right? The rest of the list filtered. So I handle that has with this function here, which should be of course a side effect function wrapped in the same monad m, and that function is gonna is will receive the rest of the list here. I had renamed that. I named that ys, but I don't know. Well, yeah, that's good. That so I built a list here with the head element because it should be included, right? Because it's true here, and the rest of the list, and otherwise, if it's received false, uh, I should just return that. So it's pure identity, right? So pure identity. So it's gonna just return that. I can't just return the rest here, I guess. I can do that, of course, I can do that. I don't need to process that way because I'm calling pure here. So if I'm calling pure with rest here, uh, let me see. Don't know. I need to. Yeah, I can't do that because I need to have a function that take the value, the Boolean value here. I have that here, right? I have that here. Yeah, I have that here. So, and that function should return what should return? I don't know the list itself. I guess that's gonna be okay. Let me see. Just for to be sure, let's move that parenthesis here. Okay, we still have a problem here. Let me see what is that. In group filter M, while check that expression apply pure process MV F and XS has type M0 list A1. So okay, it should have the M monad and the list. Okay, makes sense. While trying to match type M0 list A1 with type list A1. So I am not wrapping that process MV over that M. Why he's trying to match list A1? Where does list is come from? Process MV takes a boolean value and returns a monad value. Rest is a monad. And in case of true, it returns the return from this function here. Maybe this is a list and not a monad. The f here, if I pass an fe, what I'm doing here, I am applying this on that. So I'm applying fe to b on fe, and it's returning fb, which is gonna be that list. I see. So I'm trying to apply a list I am trying to apply a list here over that monad. It does make sense. How do I turn that into monad? Okay, this return a list, right? It should not be returning a monad because REST is wrapped in a monad. It's the same f, right? So this f here should not be a list. This f is this m. Let me see. This m here. It's not a list. Why he's saying that this thing is a list? Let's put that in bind terms to see what's happening here. So I'm taking I am unwrapping the boolean value here and calling process mv with that, and that should return the m monad. So I'm doing that with that, okay, and I am doing that with that because it's just a recursive call on that. Okay, that should work. It worked. Oh, look at that. It works. I don't know how. I just collect things together. It just works. Oh God. So let me save that. I don't know why my the PureScript ID server is taking too long to compile in my machine. Starting PureScript idea server. I need to upgrade my computer because that would be related. Don't know. So let's commit that. H. Okay. Let me just speak very fast the solution of the author to that. I'm curious to see how they solved that. Look at that. He used do notation. I was feeling that that would be the solution too. Let me see and compare then. I should use do notation because they must the exercise for that. I blame VS Code. I see. I never used Emacs before. Goodness, yes. Uh, what is that? Never seen that before. I can. Ah, okay. Ignosis. Now it makes sense. Let's put that. I don't like to use that way, but let's just see that side by side. So filter the notation is a lot better. Now look at that. At least for read, at least less character, right? Filter So I have a function head and tail. Ah, look, I can use. I was wondering if I can use pattern mate that way too. Extract list. Filter only requires applicative in Haskell, by the way. hmm So what he's doing here is taking the he did the same thing but with the notation. You see that? So he takes the b. In my case, it was this value here from process imv. Then he take xs is what is the rest. Yes, it's the rest. So my rest here, he did that with a simple denotation. But there is there is no problem with the different monads here. Let's see. F returns m. Okay. Filter m returns m. Okay. Yeah. No problem here. And he called pure if b, like I did with pattern image here. Then x with okay, it's the head element. Okay. Next s line with the rest of the list. I use a lot of cons and I should use just that. A lot is simpler. else XS line. So he did the same thing that I did, but I didn't use do notation. He used that. I use I use pattern animating, and there's a recursive call. He did that here. Okay. Yeah, he saw the same way. Just write that, wrote that with the notation. I should be more familiar with that. Let's try to use that more. Okay, now the next exercise is to every monad has a full functor instance given by map functor e do x uh, yeah, so it takes let me see, map fe do take out x from e, so e is a functor, right? F is the monad. No, wait. Mm. E, why he is extracting x from e? Let's see the functor type class here. Right here, functor. So functor have this type signature. It takes a transforming function, passes a function type constructor f, turns the type constructor with that b. Okay, for a given type f. Mm-hmm. So map, let's put that here. Let's just check. Oops. Whoops. What is it? Okay, here. Because in case of monad, let me see. A monad is also applicative. So it means that it can be applied, it can store side effect function. How that's possible? That's the thing that I'm trying to understand. Pure fx. Just a second, I'm go to the bathroom. Be back. filter only requires applicative on Haskell. Yeah, because I have seen that there is a difference. Monad from PureScript is applicative and bind. They are different. Like bind allow you to use um, bind function, and applicative allow you to use pure to wrap uh, a given value, and apply allow you to write to call apply function and constrain about functor. So it's more like reusable, you know. You can split parts together, split parts of from monad, I guess. I don't know the usage of that, but that's probably one. So back here, every monad has a default functor instance given by. What this means is that monad is also a functor, so it have map function, but why with do notation? Let me see how that compares to bind. I feel that bind is probably better to understand those things. So it's like taking out e with x and calling pure over fx. Let me see. Something like that. Okay. So taking out x from e, and e, we know that e yeah, x should be that b, right? No, wait. I have a function. And I have a fe. So x should be that e, right? Yeah, x should be that e. Then I call f with that x value, and it returns b, and I wrap that again in the same functor f with pure function. Okay, no problem here. Is the monad also provide that for n monad the following holds: lift f pure e pure b is equal to pure f e and b, where the apply instance use the ap function defined above. Recall lift2 was defined as follows. Is the monad laws, which are monad laws are, let me see, right identity, left identity, and right identity. Okay. Let's put that here. Where apply instance use a planner of let me see which is this one. That one. Nice. This probably I don't know. It's a game more pop. I don't know. I don't know what's that, but it's nice. Hmm. What's the size here? Really? I have played a long time ago a fight simulator, combat fight combat simulator called let me remember. I think it was F F 16 F 16 flight F F 16. I don't remember. I think it's F 16. It's not. It was not a simulator. It was like more like an arcade game, but there was some. Don't remember. Falcon. It was a long time ago. Let me see. Oh, yeah, that was the one. I guess that was the one. Let me see. Mm-mm. Mm. There's not an image for that. With the image, I would. Let me see. Mm. I don't remember. It was a long time ago. It was newer than that. It was newer than that. It's more like no. This is explained. It's not that. Let me see gaming because I remember it's not like a simulator. It's more like a game. It was very very real, but I don't know if it was considered like a simulator in a game. Hmm. Let me see. It's not that. I remember there was a series of games, and I remember that you can like replace things, like there are missions that you need to accomplish, and there are uh, it was more like something like that. I remember there was a series like there was F 16, there was MiG 29, I guess. It's Falcon. Oh, nice. So that was the one. But I remember the graphics. It was not so bad. Maybe because it's it's a long time ago. We don't have parameter, how bad it was before. Check the link. Let me see. Yeah, it was that one. The graphics was that way. There are more. Ah, here. Nice. Yeah, that one. It was so good, the graphics. Now I'm trying. I'm seeing that's too good. Ah, I see. It was nice. I remember. I had a joystick to play that a long time ago. Whoa! It has like what 20 years, maybe 15, 20. I have like now 30 years, and I remember that I was playing that in I don't know 12, 12, 13, 13 years old probably. Yeah, it was a long time ago. Oh, they still play that? Nice. Like flight simulator nerd. I was that before. That was my first simulator contact. After that, I had played Microsoft Flight Simulator 28, I guess. I see. I had played this Flight Simulator 28 a long time ago. Then I have played the series of Flight Simulator up to the I guess that was this one. Yeah, it has the Concorde. Oh, I played it so much, so much. I like that a lot. The one that has come with Concorde. Uh, oh, that's nice. Then I played after that. I played the X-Plane Simulator, which in graphic X-Plane 9. I guess it was X-Plane 9. Yes, or 10. I guess that I played this 9, and then I played this X. Which look at these graphics. It's very good. Whoa, nice, nice graphics. Whoa, really nice. Recently I have played one for Xbox. More recently, I should remember. It's a newer one. Very nice too. Um, nice. But it was more like a yeah, Ace Combat. I have played that. I guess that was that one. Let me see. Very nice though. Rogers is more like arcade, not so simulator. If it was that, yes, I guess that was the one. Let's see some gameplay here. Yeah, that was the one. But I prefer simulators. I prefer that simulator than game arcade. Game arcade, like, I play a little and okay, I get bored. But simulators, because it's too hard, to play. I don't know. It feels more challenging. Use monad laws to prove that unmonad to prove that for any mod the following holds. So I need to prove that using monad laws. Let's see what's that AP function. Let's remember. Monad have this AP function. Let's use the source code for that. It's a do notation. You see, it's the same thing. So to apply a side effect function wrapped in a monad to a given monad value, it takes out the f value. So it takes out the function right here, the side effect function, the f line, and it takes out the value from the monad in the second parameter, and then call pure, which is gonna wrap in the same monad the result of calling the side effect function over that e wrapped value. Okay. So I need to prove that, use monad laws to prove that for n monad the following holds. How do I don't know how to do that. The monad laws are that me see. Lift is gonna. Okay, I'll do some pause. I'll pause over here to launch. I'll keep the stream in BRB mode because I will return very soon. I spend all day on that, probably, right? So if you want to back late, or you can just stay there and wait. I'll be right back. Right, right. See ya. See you soon. Back. Hmm. The send switcher is inactive. Okay, now it's active. Hey. I I'm so lazy. So I need to use monad laws to prove uh, that thing here. Those laws are left identity and right identity. I guess that I need just to replace those things with these things and see if they are equal, right? Guess. Let me see. Let's try to replace those interests with the left thing. So, for example, a pure E something should be fx. That's right. That's probably right. So, f. First, I need to be sure if those letters are matching. Otherwise, I'm gonna be in trouble here. So let me see. First, the lift 2 type signature here. How do I do that? I just I guess that's better just to replace all the matching letters so they are not never equal, so no chance to misinterpretation. Yeah, let's do that. For example, here we are using f and x, right? So we will replace both. Actually, x there is no repetition, so let me put use proof by necessity. The docs say they hold, so therefore the rules must hold. Proof by contradiction. Assume the laws do not hold. The docs must be wrong, which they are not. Like try to break the thing with I don't know, place some monad there because the truth being held here is that those things are equal, right? Would be not easier to just replace like for example I have one truth here and I can for example replace those things. Just let me just replace this F with T to not use the same letters, and in place of this thing here I place like uh, in place of pure, every pure something, I replace that with this. But it's not just pure X, right? It's this thing here. Hmm. there's no such case here. Can use previous proof. Here I prove a few of these. IIRC. What is that? Ah, okay. If I remember. Sorry about that. If I remember correctly. Uh-huh. Yeah, I proved the right in the left, but I have not committed that yet. I guess let me see here. Maybe it was in chapter 7. Let me see. Yeah, I did that, but I have, I have not committed that, so I don't have that anymore. But I can assume that this thing is true and replace all those expressions here, or all those expressions here, by the equivalation, right? I have proved that and that before, the left and the right identity. But for n monad, the following law. Why? Yeah, to prove that, I just need to relate those things with some law, right? Like, for example, let me see. If I replace that, I need to have an expression with something like that, or something like that, or something like that, or something like that. I can see the implementation here for this function, actually, right? And I can prove based on that implementation. That's probably better. I have this implementation. If I replace that implementation, I need to prove that thing. Yeah, I need to prove that thing. I need to prove that thing. To prove that thing, the thing that I'm not understanding here, how can I use the monad laws to prove this thing are equal? Can I replace those expressions? That was I thinking. Like, I can replace. I could like replace this expression with some law. I don't know. Let me see. Proof by necessity. If it had better be true, if it had a, if it had better be true, or the interstructure of an animal is crumbed to the ground. And the other way is proof by contradiction. It's like saying on a test. The test asks me to prove this thing. The test asks me to prove this thing, therefore it must be true. Mm-hmm. This is the test by proof by contradiction or proof by necessity. Say they hold behold. Let me see. The proposition we prove P is assumed to be false. That's it. No P is true. If it is then shown that no P implies two mutually contradictory assertions, key and no key. Since key and no key cannot be both true, the assertion that P is false must be wrong, so P must be true. Let's see one example of that. Classic proof, recognized proof, described transitioner. To math. You should know that 80% of what's come out of my mouth it's so joking. Bad joke, bad joke. Okay, I take that on account. Ah. Classic proof of contradiction from mathematics is the proof that square root of 2 is irrational. If 2 are rational, square root of 2. Okay, if it were rational, it would be expressed as a fraction a and b in lowest terms. While a, b are integers, at least one of which is odd. But let me see odd. Okay. Because okay, odd makes a number not integer, like division with other numbers make it this rational number. Okay. But if a divided by b is equal to how do I call that? Square root of square root of 2. Yes. If a how do I call that? A over b, right? A divided by b. A divided by b is equal to square root of 2. Then a power 2 is equal to a over b. Okay. A over b is square root or root of 2. Then a power 2 I can just call square of a, right? A square of a, is equal to 2b 2 square of b, 2 times square of b. Let me see again. Square of root is irrational. If it were rational, rational means a number that can be expressed as quotient of a fraction, which the number is a rational number. It's hard to me because I have to translate that to Portuguese to understand how I normally understand. uh, so let me see here. What is it? Here, rational numbers. Okay. P over key of two integers, a numerator p and another denominator key. For example, minus 3 over 7 is a rational number as is where every integer. I see. Okay. The set of all rational numbers are factorial to be as okay. This key. Okay, I remember that. Let me see. But if you're rational, it would be expressed as a fraction a over b in lower terms. A reducible fraction is a fraction which the numerator and denominator are integers. Okay, that have no other common divisors than 1. In other words, a fraction a over b is irreducible if and only if a and b are coprime. That's this. If a and b have a greatest common divisor of 1. In higher mathematics, reducible function don't care. Okay, that's they are using the fact that even number an even number can be written as 2n for some integer n, okay, and an odd number b can be written as 2m plus 1 for some integer m. Eventually you come to the conclusion that they can both must be multiples of 2. Both what they are using the fact that the even number can be written as 2 for some integer and an odd number b can be written as 2m plus 1 for some integer m. Eventually you come to the conclusion that they can both must be multipliers of 2 and therefore not the lowest term. I see. So if it were rational, like square root of 2, it was expressible as a fraction a over b in lower terms, where a and b are integers, unless one of which is odd. I see. Where a to b are integers, unless one of which is odd. But if a over b is equal to square root of 2, then square of e is equal to 2 times square of b. Why? It's a transformation. Let me see. I don't know, probably there is some law here. Therefore, a square should be squared a must be even. And because the square of an odd number is odd, that in turn implies that e is itself even, which means that b must be odd because a over b is the lowest terms. On the other hand, if e is even, then a squared is a multiple of 4. Okay, if a squared is a multiple of 4 and a squared is equal to 2b squared, then 2b squared is a multiple of 4, and therefore b squared must be even, which means that b must be even as well, and it cannot, right? So b is both odd and even, a contradiction. Okay, therefore the initial assumption that square root of 2 can be expressed as a fraction must be false. So this is the proof of the contradiction. I try to use that with some example, and that would imply, like, I take the form as it was not true, like if the test like it was lying to me, and I try to prove that the test was lying to me. When I do that, I reach an impossible situation and a contradiction, right? So to do that with a call like that, how I would do that? Because the example here is, he's saying, the test is saying that monad allows or for any monad. Actually, let me see. Use the monad to prove that for any monad. So the thing that he's saying to me is that lift 2 over the function having passing 2 monads, I guess, or 2 functions, 2 monads probably, is equal to the monad having call f over each monad value. So to prove that's wrong, I should assume that is not true. So they are different, and try to do the next sample and reach the contradiction, right? I see. I guess. I gotcha. So, for example, I should call lift 2 here with some f. And okay, I need to prove this. They are not equal. I don't know if this is enough or not in PureScript, but I keep that for now. Negation operator for PureScript. I can't search for that right here, right? Let me see. Is that? Let me see. Not. I don't care. I use not, so. That's my not. Can I use like that? If not, I use like, I don't know if I can use that way, but there is no influx operator here. Influx, not operator. I should use something like that, right? Hmm. Would be something like, I don't want to care about that right now. Let's keep that. Okay, so to prove that, let me see. I need to make a different, like, who's F? Let me see. Who's F? Here the type signature. F is an apply type constructor. Okay, so it have apply function, right? Yeah. So I can say that F. Let's put something else like, I don't know. Let's call this M for now. And M should be M should be, I don't know, non apply. Maybe is apply. I guess it's right to use that like not in general form. Just to recap, so apply have apply member. Okay. So I must say that I don't know, maybe int. So I can say that just one, right? And n should be maybe int. So like they should be different, right? Different values. Let me see. Because I want to prove that lift 2 is not equal. So calling f lift 2 m, is that right? It makes sense. F should be a function, right? I'm confused those things here. Wait a second. F right here is a function. It's not the same F as that F. So f, I must have some function. Let's call this, I don't know, just fn, that what's the type of that? That gonna receive a given e, which is int in our case, right? Arrow, another int, arrow c, who is c? Int 2. So that fn should be, let's say that this fn would receive those values and sum them together. I don't know, because we can sum because it's int numbers, right? And it returns the c value right here. So lifting that fn which is applying, no, the function is not, no, f apply is the is the maybe. Okay, the maybe here is apply. So calling f and a and b, which in our case should be m and n, that is equal to, should not be equal to, actually I see, calling this thing, right, because here this thing, so calling pure m and pure n should not be equal to calling pure fn m and n, right? So what happens here? How do I solve that? No, I replace that with those values, like just 1, just 3, just 1, just 3. That would be equal to pure wrap the value on the monad. Who is that monad? Not monad, right? Functor applicative, yeah. I should have, I see one thing here. F should be type to type, so it should be a kind. Pure received that value. Okay, so it's okay, no problem here. Returns the the monad. The monad in this case would be what? The lift, the fn function returning. I guess I'm doing something wrong here. I'm using mn in wrong way. They need to be the same. No, they need to be the same. Okay. Okay. No, it's right. Mn is the same because of this, right? I guess that fn should return a functor because how they gonna infer that pure? I see. Yeah, mn should not be a functor, and me must be values. Yeah. So like they must be 1 and 3, for example, right? Now it's right. And here I am wrapping 1 on the maybe functor, hit 3, same as 1 and 3, right? Now it's correct. Now I know that I need to wrap that on some functor, f functor. But how do I know who is f? That's impossible. Possible situation. What lift does, let me see. Type signature here, okay. It extracts the f from the mhm, from the given value. So this given value should be the monad, but how they would know? How Lyft knows that F is a maybe is I don't know, because it won't take that from the function fn. It's taking that from the values itself. So for example, if I'm passing, yeah, to do that I need to replace that pure with a type constructor for a type which is apply. But how he's asking to me to prove that if I cannot be sure about monad? Can I like specify pure for something like, hey, my pure do something very magicy, which is taking an int and returning a maybe int. And my pure takes x and returns, I don't know, just x. So I can call pure that way, and I'm obeying to the type signature, right? So I can replace that pure with just 1, just 3, and just fn 1 and 3. Uh, what about lift 2? Okay. Lift 2. Let me copy paste that. Wait. Uh-huh. I see. So lift f pure a pure b is equal to okay. Right to hand. This is, I'm not sure. What is that? What's in the left hand? Left hand, right? That's a, it's true. Left hand here. I see. You're resolving this left hand. Then on the right hand, we are resolving this right hand here, right? pure uh pure F, so A to B to C. Okay, this thing here. Oh, it's the contract. This is the okay. This is this, right? Pure. This is this. Yeah. Uh-huh. So this is the part here. Okay. And this, if I am correct, this is the implication for that. Let me see. Something like, let's see, pure. It's something like that. It's equal. But there are two equals here conflicting. How do I solve that? This is the right, right? So let's fix that. This is the one is left. Ah, they are exactly equal. Okay, I see. They are equal. They are all equal. So pure having pure F A B, okay, is equal to pure C. Hmm. I guess that makes sense. If you remove A and B here, you are not passing AB here. Then the remaining is pure C. Do you use, did you use some law here to do that replacement? Let's see on the left side. Left side. Is F here, okay. I see because left. You just applied AB to. I just applied AB to ABC. Just an application. I see. Yeah. Uh huh. Okay. Okay. I see. Okay. MC. Right. Right. Okay. So this is more like an implication, right? So that's implied on this code, which is implied on this code, like in sequence. On the left side here, I have this. Uh, that was not. I was not taking in consideration. Lift is changing the function to receive uh, the functor, right? The rapid functor values. So he's receiving those aims here. MA, MB, MC. and just see. It's because of that, right? Yeah, here is the returning function. But the last one has an empty. Four is equal to plus 2 plus 2 is equal to 4. Equal, right? And I see. I could write that, right? There is not a missing M right here. Why no? Look at the type signature of lift. The C should be wrapped in the same F. Ah, sorry. Okay, this is the returning from lift. So yeah, this MC is right here. Correct. But I have to say one thing. That's unfair because I was trying to do contradiction. And here you are just proofing this thing. But okay, I got the point. So here they are equal, right? In the last sentence they are equal. Okay. I put that. I keep that here. But how do I achieve that? Let me see. How do you know that? Ah, it's just applied. Yeah, you say that. And that one here, let me see, the left hand is just applied. You apply that function to both values and it remains. It should not remain C. No, because the MC should be here. No? Look at the type signature of lift 2. I mean replacing even the returning value to the monad one, to the functor one. So applying those to those values, it will remain that MC. How that was before? Yeah, so it's right. Oh, it's okay. The exercise is just asking to prove, but it was not use the Monroe laws to prove. I guess how I mean how can monad loss prove that? Let me see. The left identity one and the right one. Let me see. Even if you add the MC, it will still be true. Point is that it returns MC. Mm-hmm. Point is that it returns MC, and Pure has a constraint for monad M. Mm-hmm. So Pure C is equal to MC for our monad M, so L8 and R8 should be equal. I have translated to the reader. Mm. My worrying is about how monad loss could help to reach this point here. Pure, let me see, acts like pure something like pure some x like this would be equal to that function applied to that x. So like MC is equal to PSC, that is equal to this, right? This thing here, right? Actually this thing here. No, actually this thing here. But yeah, Molan's laws is saying yeah. But I guess that's a little relationship here. Look at the type signature, for example, here. This TX is this MC. That is equal to pure X, so pure C, you see? And that is equal to that. Don't know how you comes from that to that. That function is the fn right here. Let's see left on the left hand side how that would help. The x is MC. Is right to say that MC is TX. Let me wait a minute. It's not correct to say that. No, I am correct, completely wrong. What is T in this context here? T is a function. Uh, I don't know. I don't care. I'll keep going. Like I was saying, A to B to C applied to A to B is equal C. So clearly pure A to B to C applied to A B must be equal to pure C. Yeah, makes sense. Makes sense. Yeah, makes sense. It's like it's like taking out a rabbit from the how to say that? You know those magicians that takes out a rabbit from how is called those things? Magic and cap? I don't know if it's cap, but you know what I mean. Hat, yes. It's like taking a rabbit from the hat. Look at this function that I just created here to solve this problem. And how I apply that to those values. Okay, let's keep it going. I'll not spend so much time on this. This solved the last exercise. I'll keep this here just to reference if I want to check out that on future. I regret of not having saved some those laws proof here that I've made before. That's the problem. Okay, let's be effects. Let's keep going. We will now look at one particular monad which is of central importance in PureScript, the effect monad. The effect monad is defined in the effect module. It's used to manage so-called net side effects. If you are familiar with Haskell, it's the equivalent of IO monad. So that's the effect monad. Why I did see that? I guess that I have seen that in Haskell. I've seen that in Haskell before. Effect monad. Let me see package. Effect. Haskell have effects too. But let's keep it going. What are net side effects? They are the side effects which distinguish JavaScript expressions from idiomatic PureScript expressions. I see. Which typically have free-form side effects, which typically are from free-form side effects. Free from side effects. They are side effects which distinguish. Brian? Yeah. JavaScript expression from idiomatic PureScript expression, which typically are free from side effects. Some examples of native effects are console.io, random number generation, exceptions, writing, mutable state. And in the browser, the manipulation, XML, HTTP requests, AJAX calls, interacting with WebSockets, reading from to local storage. We have seen a plan of example of non-native side effects. Optional values are as represented by maybe data type. So this is non-native, right? Arrows as represented by either. Multifunctions as represented by arrays or lists. Multifunctions. Okay. Note that the distinction is subtle. It's true, for example, that an error message is a possible side effect. Okay, let me see. It's true, for example, that an error message is a possible side effect of a JavaScript expression, in the form of an exception. In that sense, exceptions do represent native side effects. And it's possible to represent the use effect, because an error message is possible side effect of a JavaScript expression, the form of exception. In that sense, I see exceptions do represent native side effects, and it's possible to represent the use effect. However, error messages implemented using either are not side effects of JavaScript runtime. I see. So it's not appropriate to implement error messages in that style using effect. However, error messages implemented using either are not side effect of the JavaScript runtime, and so it's not appropriate to implement error message in that style using effect. So it's not the effect itself which is native, but rather how it's implemented at runtime. So it's not the effect itself which is native, but how it's implemented at runtime. I'm not so sure if I understand that. Maybe if we see some example of that. Side effects and pure. In a pure language like PureScript, one question which represents itself is, without side effects, how can one write useful real-world code? Without side effects, how can one write useful real-world code? The answer is that PureScript does not aim to eliminate side effects. It aims to represent side effects in such a way that pure computations can be distinguished from computations with side effects in the type system. In this sense, the language is still pure. Values with side effects have different types from pure values. Values with side effects have different types from pure values. As such, it's not possible to pass a side effecting argument to a function, for example, and have side effects performed unexpectedly. An effect, it's like an effect is to manage side effects, to manage native side effects of the JavaScript language. For Haskell, it's here. If you're familiar with Haskell, it's the I/O monad. So it's a monad, right? That you can write, that you can handle side effect JavaScript side effects. Like there are some examples: console I/O, random number generator exceptions, reading write multiple state, do manipulation, and things that you need to have a way to. Yeah, it's a monad. Okay, the only way in which side effects managed by the effect monad will be presented. Why don't they treat memory manipulation as side effects anyway? I guess that's not such memory manipulation. The only thing that you need to manipulate with PureScript is the it's the function piping. You never assign something to a variable. So if you never assign something to a variable, you are not manipulating memory. You're just piping things together. The only way with side effects managed by effect monad will be presented is to run a computation of type effect E from JavaScript. The only way with side effects managed by effect monad we will be present is to run a computation of type effect E. What does this mean? The only way with side effects managed by effect monad will be presented is to run a computation of type effect E from some JavaScript. I guess that I understand that. Let me see. The spec of Build tool and other tools provide a shortcut by generating additional JavaScript to invoke the make computation when the application starts. Main is required to be a computation in the fact monad. Hmm. The fact monad. The fact monad provides a well-typed API for computation with side effects. While at the same time generating efficient JavaScript. Let's take a closer look at the return type of the familiar log function. Effect indicates that this function produces a native effect console IO in this case. Okay. Unit indicates that no meaningful data is returned. You can think of unit as being analogous to the void keyword in other languages such C, Java, and so on. Log string effect unit. Aside, you may encounter IDE suggestions for more general and more elaborate type log function from effect class console. This is interchangeable with the one from effects console when dealing with basic effect model. Reasons for the more general version will become clear after read about monad transforms in monad inventories chapter. For the queries and impression, it works because there is a monad effect instance for effect. Log monad effect m string m unit. Okay, I guess. Now let's consider effect that returns meaningful data. The random function from effect to random produces a random number. Random effect number. Here's a for example of just a second. I'm trying to see if I should be studying that because because tomorrow content was gonna be around Haskell, and let me see here the required content. Just a second. Here, the course topics. The course was suggesting me to read Learn Your Haskell. Oh God, 400 pages. But it probably gonna go from basics. I have also this. Let me see difference from. Let me look for that. Just a second. It was here. It's an article that I have put here in my reading queue. So there's this article that show all difference between PureScript and Haskell. Let me see about this effect type class, just to see if I need to learn that right now. It can just move that to after. Okay, at least at least uh, this doc here is not showing nothing about the effect monad. My guess is that they are the same. What is the for Haskell? It's gonna some praise for it's gonna. I guess that this this effects monad are the same from Haskell. So let's keep going. Where we are here, here. Okay. So now let's consider an effect function which returns meaningful data. The random if function from effect random produce a random number. Effect number is a full example program found in test random purse of the chapter exercise folder. So random is here, log show is here, main effect unity do random, take random number and log show. Because effect is a monad, we use do notation to unwrap the data it contains before passing this data to the effective log show function. As a refresher, here's the equivalent code using the binary operator. So effect unit random, take out the value and passing to log show. Try run this yourself with Spaghetti run main tests random. You should see a randomly chosen number between 0 and 1 printed in the console. Aside Spaghetti run the fastest searching in the main module for main function, it also may specify the alternative module endpoint using main flag, as is done in the above example. Just be sure that the alternative module also contains a main function. Okay. Note that it's also possible to generate random, technically pseudo-random data without resort to impure effective code. We cover those techniques in generative testing chapter. As mentioned previous, the effect monad is of central importance to PureScript. How is that in Haskell? How would be a main function in Haskell? Let's see. Haskell. I just want to see one example for that. IO something, right? Yeah. Get char has type IO char and so on. You think type IO char as meaning take the currency, reroll, do something to it, and return a char and possibly change reroll. Let's see the main. So Haskell is even more pure than there is not such a unity. Huh? I should read this thing here to be able to work with Haskell, probably in Pluto's platform. Introduction to IO. Haskell separates pure functions from computation where side effects must be considered by encoding those side effects values of a particular type. Specific value of type IO is an action which is executed to produce a value of type E. So an example, get line IO string, put line string IO, not that the result value is an empty tuple. Random IO, random E, IO E. I mean, this knowledge, you can write a hello world program, IO tuple, M tuple, put string, hello world. No, so this is great, but we are showing chain affecting you can also primitive so compose and chain to get IO actions. Okay, so there's not such effect in Haskell, like here, effect units, because on the Haskell side of things, we are actually handle using things in the matching, right? And for JavaScript, we are actually running on some backend, so we are running on JavaScript runtime. So that's why PureScript begins with effect and Haskell begins with IO. But they are both monads and they probably work the same way. As mentioned in previous effect was the central importance of PureScript. The reason why it's central is because it's conventional way to interpret with PureScript for any function interface, which provides the mechanism to execute a program and perform side effects. While it's reasonable to avoid using foreign function interface, it's very critical to understand how it works and how to use it. So I recommend read that chapter before doing any serious PureScript work. That said, the effect monad is fairly simple. It has a few helper functions, but aside from that, it's not done so much except to encapsulate side effects. Not so much except to encapsulate side effects. Exceptions. Let's examine a function from node f aspect that involves two native side effects: reading mutable state and exceptions. Read text file. It takes an encode value, a string value, and returns a effect string. If we attempt to read a file that does not exist, if we attempt to read a file that does not exist, node encoding file node fs sync read text file effect unit do lines read text file I do not exist log lines. We encode the following exception. Why this thing is returning effect string? Maybe it was because it has come from a side effect computation. If you attempt to read a file that does not exist, and you read TF8 we record the following exception: no such file directory I do not exist. To manage this exception gracefully, we can wrap the potentially problematic code and try to handle the outcome. So try maybe it is return a mail case result of returns either lines log contents append to lines. This return effect unit left arrow I could not message error. Try runs an effect and returns try runs effect. Okay, and returns eventual exceptions as a left value. If computation success, it gets wrapped in the right. Try effect E, effect either error E. So either can given an effect, it will return an error or a value. So it's like you run the function and evaluates the result. Its result. It can also generate our own exceptions. Here's an alternative implementation of data list head, which throws an exception if the list is empty, rather than return a maybe value of nothing. Implementation of list head, which throws an exception if the list is empty, rather than returning maybe. Okay, so exception head, list of int, effect, int. Exception had case L of a list having the head and anything returns the fact of that anything. Otherwise, throw an exception of an empty list. Note that exception head function is a somewhat practical example, as it is best to avoid generating exception in PureScript code and instead use non-native effects. Is such is either and maybe too many errors and missing values. So he's trying to run a runtime error exception here. Okay. Mutable state. There's another effect defined in the curly brace, the ST effect. The ST effect is used to manipulate mutable state. Another effect defined in curly, the ST effect. The ST effect is used to manipulate mutable state. As pure fractional programmers, we know that shared multiple state can be problematic. However, the ST effect uses the type system to restrict sharing in such a way that only safe local annotation is allowed. The ST effect is defined in the control model as ST model. To see how it works, we need to look at the type of in these actions. New, read, write, modify. New takes anything and I don't know what's that. str stref re can also take stref re and return that STRE. Write and modify. New is used to create a new mutable reference cell of type stref_re. It can be read using read action and modify using write and modify actions. The type E is the type of the value stored in the cell, and the type R is used to indicate a memory region or chip. I guess that's answer your question, JPGP. Why they don't treat memory as side effect anyway? I don't know. This is maybe related to the thing that you asking. Here's an example. Suppose we have a simulation movement of particle. Let me see, just here. New is to create new mutable reference cell of type strf_re, which can be read using read action and modify using a write and modify action. The type E is the type of the value stored in the cell. And the type R, this one, okay, is used to indicate a memory region or heap in the type system. Here's an example. Suppose we want to simulate the movement of a particle falling under gravity by introducing a simple update function with a large number of small time steps. We can do this by creating a mutable reference cell to hold the position and velocity of the particle, and then use a for loop to update the value stored in that cell. I can even call for modify new read st for and run. Simulate takes a number, int, and returns a str number. Simulate xv0 on time. Do takes an ref, new x and v, passes a new record. For 0 times 100, run modify, zero O. So O is like the old value and returns its new value. Final read that half pure final dot x. So it will return str number for NR. At the end of the computation, we read the final value of the reference cell and return the position of the particle. Note that even though this function uses multiple states, it's still a pure function, so long as the reference cell ref does not allow it to be used by other parts of the program. We see, so have here, yeah, is not being used anywhere. We see that this is exactly what STFX allows. To run a computation, so I can use read, write, and modify only with halves that I have access. So which has been created in the same do structure. Note that even though this function uses multiple states, it's still a pure function. Okay, we see that. To run a computation with STF effect, we have to use run function. So run receives a given effect STRE and returns that E. The thing to notice here is that the region type R is quantified inside the parentheses on the left of the function R. This means that whatever action we pass to run has to work with any region R runs over. However, once our reference cell has been created by new, its region type is already fixed. So it would be a type error to try to use the reference cell outside of the code limited by run. This is what allows run to safely remove the ST effect and turn simulate into pure function. Simulate line number into number. Simulate x0 v0 time run simulate x0 v0 time. Can even try run this function terminally. Inline the definition of simulate and call run as follows. In the compiler, we notice that reference cell is not allowed to escape its scoping and can safely turn ref into var. Here's the general JavaScript for simulating line with run. Note that this result JavaScript is not as optional as it could be. This is a serious for reference, this is Generalize JavaScript for a non-inline form. Mm. The ST effect is a good way to generate short JavaScript when working with locally scoped mutable states, especially when used together with actions like for each, and while, which generate effects efficient loops. I see. Mm-hmm. And we have done effect. I'm not seeing that today. I will finish by here with this exercise block because we have just fast forward this mutable state. So I will try to recap this again and solve this exercise, but I guess that's for now is enough. Let me push this thing. I have a fairly understand about effect monad, and I guess that now I'll take a pause for some coffee, and also I'll do something else. I still want to add these docs here to see the difference between Haskell and PureScript. Then I really want to read something about that I/O, because I would need that for tomorrow. So I will do that. I'll try to run some Haskell code. But yeah, that's it. There's even ST here too. I'm missing some ST. So there's ST here too. What's missing package? I don't know if I just go forward with that, or if I begin with IO monad for Haskell. I will add that the IO thing here. I don't know. I guess that this would be better because I have some exercise to do here. And it's best what it has more, yeah, it's more similar to what we are doing up to now. So yeah, I try to solve this exercise in the next stream, and also read some introduction to IO on this page. Then I can go deeper in the wrapped role wrapped role for Haskell IO. Right, so I add this to my read list, and this is where we want to keep going at today. Right, so thanks again for watching, and I hope that I probably be back tomorrow, but I will not. I will go through first to the first lesson of Boots Pioneer program. Then finish that lesson. I will begin. I will begin. Actually, I can begin stream that, right? No problem with that. So I try to stream that um, that learning through Plutus platform, and I'll keep you stream after that with those contents as we can run that in parallel and try to reach a place where we can keep going with the cursor without interruptions on the learning process, right? So that's it. For who is want to check out the code, the repository is right here. I have pasted that in the chat too. So thanks again. Bye bye. See you soon.